All right, let's do some review of what we did earlier on the periodic table. The periodic table organizes all elements in a very specific way that is meaningful to scientists. Okay, so here's a scientist, right? And you remember, periodic table uses columns and rows. Okay, so the rows are called the periods. And the columns is called the group. Right? So periods are the rows, columns are groups. So this organization helps scientists understand why elements act as they do, predicts how the elements will react with when combined with others, and keep track of any new elements that are found or created. So let's do a review. The periodic table organizes all elements according to their protons. Okay, the protons, right? So one proton is equal to the hydrogen atom. We give the symbol H. 2 protons gives us helium. So you can tell it changes the element altogether. All right, so when we add a proton, it's no longer a hydrogen, which blows up. When you add another proton, it is helium. Now that happens in a very interesting space. The sun creates these elements. So the sun has enough heat and energy to bash two hydrogens together to get a helium, and then so forth. So that's interesting about that. So we don't do this very often. I mean, it's not something we do, but the positively charged, now if you think about it, positively charged, positives don't like positives. So another positive, they repel each other. They do not want to be close to each other. But if you get into the sun, all that heat and energy, you can bond things together. All right. So remember, the proton is the positive charge. And I spelled it wrong. It's in the nucleus right here. Let's make these the positively charged. The electron is outside. And that's negatively charged. Now they are attracted to each other. So they want to pull each other together. Remember, the proton is positively charged. Oh, they're using the red ones. Oh, that's good. Positively charged. It's in the nucleus. Proton is positively charged. It's found in the nucleus. Electrons are negatively charged particles that travel in orbits. So they're not in the nucleus outside. They're whizzing around. This way of organizing the elements keeps those that are similar grouped together. So this is group 1, and all the group 1 are in this column. They call that column group 1, and then group 2 are all similar. You'll see that the hydrogen is in group 1, but it is not really it's not a metal. So all these other ones are metal. So it's unlike it's kind of out of place. I should say it's out of place, but it does have some real idea, some characteristics of those metals. So this column 18, helium, neon, has a lot of things in common. So the periodic table is made up of columns we call groups. And rows, which we call periods. So here is a row, and this is in row 1, 2, 3, 4, 4. This is in row 4, or period 4. So if I asked you for period 4 and column 13, we could say that was GA. Okay, so there's this, it's like playing the game Battleship. So each period has elements that have the same number of orbitals. So this has 2 orbitals, so this is in period 2. So that's row 2. All the ones in row 2 have 2 orbitals. In row 3, it has 3 orbitals. Row 3 has 3 orbitals. So as you go from left to right, the number of electrons in the outer shell increases. So this one, okay, so row 2 has 2 shells, okay, but the number of electrons, so lithium only has 1 electron. This is lithium Li. Beryllium has 2 shells, but it has an extra electron there. Go to boron, still 2 shells. It has 3 electrons in the outer shell. And then finally, get to neon, and it has 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so as we go left to right, the number of electrons in the outer shell increases. So starts at lithium, 2 columns or 2 orbitals, right? And then the outer shell, the one that's furthest out, the electrons increase. This increase in the electrons also means the atoms get smaller as they go from left to right. The more electrons you have, the stronger the electromagnetic force and the tighter they squeeze the atoms down in size. Okay, so that means that ones on the way on the left are bigger than the ones way on the right, because their attraction between the two pulls them closer together. So it goes from large to small. And this is a squeezing. Right, finally, as you go from across the period, the number of protons increases. Right, so I'm going to use row 2 again, or period 2. I'm just going to call it P2. All right, so the number of protons, so lithium here has 3, then beryllium has 4. We jump over here, this has 5, this has 6, 7, 8, 9, 10. And that makes them heavier. So it goes heavier and heavier and heavier as we do this. There are also columns in the periodic table. Each column is called a group. Remember, we talked about that. So this group, then we have another group here. That's group 2. So this is group 1. This is group 2. This is group 3, and then goes across here. We don't usually do much with these, but we do use this part here. So we've kind of omit this part here. Don't do much with those. Right, and again, this is a review. These are 7. So what's interesting about the properties of the column is even though fluorine has 2 shells, it has 7 electrons. And chlorine has 3 shells. It also just has 7 electrons. Bromine has 4 shells, and it also has 7 electrons. So the same here as they go down. This helps scientists predict how the element's going to work in groups. All right, so now you know the periodic table is made up of groups, periods, and groups. Now let's look at the elements in the table close up.